Hello everyone, so today we are learning permutations. And a permutation is an arrangement of objects where order is important. Okay, for example, consider the number of ways to arrange Kang, K-A-N-G. So the number of permutations, the way it works is you have how many choices? Well, we have 4 letters, so 4 places. So we have to think. The choices for the first letter, how many choices are there? Well, I've got either a K, an A, an N, or a G. So that is 4. Now I've picked a letter, one of these 4. How many do I have left? So that's the choices for the second letter. So 3. 3 are left. Now I've picked my first and my second letter. How many choices are left for the third? 2. And then I've picked my I picked my third letter. How many choices are left for my fourth? I've only got 1 choice left. So there are how many ways to arrange the word Kang? It's a 4 times 3 times 2 times 1, which is 24. So there are 24 ways to arrange the whole word Kang. If we had a different number of letters, like a different arrangement, such as if we are arranging A, B, C. It's a little bit smaller, so it's easy to see. We have how many choices for the first letter? 3 choices. We either are going to put A first, B first, or C first. How many choices for the second letter? Well, I can either put, if I have A, I can either put a B first, second, or I can put a C second. If I pick B, I can either have A come second or C come second. If I pick C to start, I can either have an A or a B. Not done. I still got that third letter. So if I have AB, there's only 1 letter left. That's C. If I have AC, there's only 1 letter left. That's B. If I have BA, there's only 1 letter left. That's C. If I have BC, there's only 1 letter left. That's A. If I have CA, there's only 1 letter left. That's B. If I have CB, there's only 1 letter left. That's A. So how many ways did I arrange ABC? 1, 2, 3, 4, 5, 6 ways. So I could have written this one out, Kang, doing the same thing. But if you realize it's really 3 times 2 times 1, that's also 6. So that's just something to keep in mind. The smaller amount of letters, the easier it is, but you could also just do the math to understand it. I've got 4 choices times 3 choices times 2 choices times 1 choice, that's 24 choices. And the reason we're multiplying is because that's what's gonna, there are 3 choices times the 2 different choices, giving you those different options. Okay, part B for this same lettering, in how many ways can you arrange 2 of the letters? So the number of permutations now is just the choice for the first letter, that's kind of blocked off there, and the choice for the second letter, choices. So how many choices for the first letter? There's still 4 choices. How many choices for the second letter? There's still 3 choices. And 4 times 3 is 12. So there are 12 ways to arrange just 2 of the letters. So that's a permutation, and you can do it like this every time. Even after I show you a formula, you can still do it using this method. I think this method is effective every time. So for us to go further, we have to understand the term factorial. Factorial. This is written as n factorial, so that exclamation mark is really factorial. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. 3 factorial is 3 times 2 times 1, which is 6. Okay, so this is important to understand using a formula for permutations and combinations. So let's get right into that formula. The permutation formula, you have NPR is n factorial over parentheses n minus r factorial. What this means is, and you're seeing that in blue over here, it's the number of permutation of n objects taken r at a time. So in the last problem, we had 4 objects, K-A-N-G, taken 2 at a time. So we had 4 as our N, 2 as our R. So we could have used this formula to get, we could have used this formula to get 12. So I have 4p2, I would have used it 4 factorial over 4 minus 2 factorial, and I would have gotten 12. Let's use another example to make sure this makes sense. Okay. So you have 14 pairs of Converses. That's ridiculous, but that's okay. You can arrange 6 of the 14 on a shoe rack. In how many ways can you arrange the Converses on the shoe rack? So the 14 is the object, and the number of taken at R at a time. There's 6 places these shoes can go, so 6 is the R. So I have 14p6. So I have 14 factorial over 14 minus 6 factorial. 14 factorial over 8 factorial, because 14 minus 6 is 8. And then this is really cool and it needs to be understood. 14 factorial, if you remember from up here, we do 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 4 times 3 times 2 times 1. And then in the denominator, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Look how nice. Those are going to cancel. 8 all the way on numerator and denominator, they'll cancel. 8 divided by 8 is 1. 7 divided by 7 is 1. And so on. So the only thing you have to do into the calculator is 14 times 13 times 12 times 11 times 10 times 9, which is 2,162,160 ways. That's what's kind of hidden there. That says ways, because they're asking you in how many ways can you arrange the Converses on the shoe rack. So that's insane. There are 2,160,160,000 ways, or wait, sorry. No, I said that wrong. 2,162,160 ways to arrange your 14 pairs of shoes into 6 different places on a shoe rack. What? That's fun. All right, cool. So that's a permutation formula and how to use it. Last thing to talk about is probability using permutations. So for the Linden Parade, you'll ride on a float with your soccer team. There are 12 floats in the parade, and the order is random. Find the probability that your float is first and that the band float is second. So the first step to do is find the total outcomes. So total, there are 12 objects in 12 different ways. So 12p12 is 12 factorial over 12 minus 12 factorial. So that's really 12 factorial over 1 factorial, which is really 12 factorial. Okay, we're going to leave that there for now because you're going to notice things are going to eliminate. Number 2, we need to find our favorable outcomes because probability is favorable outcomes over total. So the favorable outcomes is the probability of all other floats. That says floats there. Kind of looks like, I don't even know what word that looks like. So the favorable outcomes is the probability of all other floats. So how many other floats are there? Well, you want your float first and the band float is second, so that takes care of 2 floats. So there are 10 floats, 10 choices in 10 different ways, so that would be just 10 factorial. When you have the same number, it's really just 10 factorial, or if it's 5p5, it's really 5 factorial. Anyway, so the favorable outcomes is 10 factorial. The total outcomes is 12 factorial. So to find probability, we do the number of favorable outcomes out of total, which is 10 factorial out of 12 factorial, which is 10 factorial over 10, 12 times 11 times 10 factorial, which is 1 over 12 times 11, which is 1 out of 32. So the probability that your float is first and that the band float is second is 1 out of 32.